Hello wonderful person, this is Anton, and today we're going to be discussing recent discoveries about the central black hole in the Milky Way galaxy, Sagittarius A star, the black hole whose official picture you see right here. Although once again, just so that we're clear, this picture actually shows us only radio light, and in this case involves a combination of different frames and is not what you would actually see with your eyes. In other words, this is the best representation, but not an actual physical image. But anyway, today we're heading back to the center of the galaxy in order to potentially solve at least one mystery. The mystery in regards to the silence of the black hole, or basically why Sagittarius A star, despite being very massive, seems to emit nothing and is literally just a black hole in the center of the galaxy. As in, it does not produce any additional emissions and is extremely quiet compared to any other black hole in other galaxies, which has been a mystery for many years. And that's of course once again, despite the fact that this is a 4.3 million solar masses in mass object and is supposed to do something. And so compared to black holes in most other galaxies, ours is very quiet. It does not seem to produce any powerful jets, does not seem to contain a massive accretion disk, and only produces very occasional X-ray emissions, which are kind of, I guess, visible in this image taken by the Chandra Space Telescope. But in this case, because it's so quiet, astronomers also believed that we should actually be seeing something entirely different that has been theorized previously and has been observed in other galaxies. Due to its silence, we should actually be seeing winds. And that's because every black hole that consumes material, even if it does not produce any jets, is still going to be producing winds, or basically galactic winds, as a result of the interaction between various types of gas and the immense gravity from the black hole itself. And so for practically 50 years, astronomers have observed nothing. And, well, officially it has now changed because this recent study seems to have discovered them. And that's of course important because not discovering these winds previously even led to certain suggestions that maybe it's not really a black hole in the center, maybe it's something more exotic, like for example a chunk of dark matter, or some kind of an exotic, massive, star-like object. Yet now, based on this study, you can find any description, researchers have officially revealed this missing breath of Sagittarius A star. And that of course tells us just a little bit more about our galaxy's history and its evolution and of course its future. But before we dive into the exact details of this discovery, let's quickly recap what we already know. And let's actually briefly start with the discovery itself. It was officially found in 1974 and was named Sagittarius A star because this was a very peculiar object inside the Sagittarius A region. The star in this case basically just denotes something weird or unusual. But it actually took decades to prove that it was actually a black hole and not something entirely different. As a matter of fact, following many observations for several decades, it was really the analysis of motion of stars in this particular region that finally proved its existence. And for this, Reinhard Genzel and Andrea Ghez won the Nobel Prize in 2020. Here they essentially confirmed the existence of these extremely fast-moving stars, some of which were moving at something like 8% of the speed of light. And the only way to explain this is of course if there is some kind of a very massive central object making them orbit ridiculously fast. And while following this, in 2022, we finally got the image. And specifically the image of the gas surrounding the black hole that was producing certain radio emissions visible to the Event Horizon Telescope. But this region is still extremely difficult to see because first of all, it's pretty far, something like 26,000 light years away from us, but second of all, because between this and us, there's a very thick amount of dust, and of course a lot of different types of gas, that essentially blocks most of the light coming from the region. And so only some light, like radio light or X-rays, can sometimes peer through the smog. And so following years of observations, researchers were able to confirm that this particular black hole just seems to be somewhat quiet. Or it's currently in its quiet state, and is not consuming a lot of material right now. As a matter of fact, it's not really doing much of anything. But something like a decade ago, researchers also discovered this, the massive Fermi bubbles. As a matter of fact, they also discovered an additional set visible only in the X-rays, essentially confirming that whatever this was possibly the result of a much more violent past Because to produce these two giant balloons of gamma-ray emitting gas, you would have to have some kind of a very powerful emission in the center. And so this implied that Sagittarius A star was potentially a lot more active a few million years ago. And so it only really appears to be quiet in modern times. Which brings us to that second problem in astronomy. According to physics, when a lot of gas falls into some kind of a central object, such as a black hole, it doesn't all go inside, and some of it ends up spiraling inward, becomes extremely hot, actually several million degrees hot, and then creates massive amounts of radiation pressure as it stays in the vicinity of this black hole. And this pressure should act as a kind of a fan or some kind of a blowing mechanism, removing some of this hot gas back into outer space, and essentially generating this constant wind pressure coming from the central region. In other words, we should be seeing a lot of this wind because the black hole is still consuming just a little bit of mass. But for nearly 50 years, nothing has been discovered in any of the observations, even though this has been seen in a lot of other galaxies. And so some scientists started to wonder if maybe our black hole is some kind of a unique outlier, or maybe this is not even a black hole at all. Which essentially brings us to this new study by Mark Gorski and Elena Morchikova. And so here these scientists from Northwestern University decided to use ALMA radio telescope in Chile and collected over 100 hours of data for approximately 5 years. And they basically developed a new way to process the data, making their images approximately 80 times sharper and 100 times fainter than anything seen before. And the point was to basically see if there is anything here that's missing and something that might potentially answer some of these questions. And to their surprise, they did discover something. Well, specifically, they found a cone-shaped cavity, which is something that you see right here, inside the clouds of cold gas very close to the black hole. And in this case, this particular void is about 3 light years long and 45 degrees wide, with this location basically being almost entirely empty of a lot of cold carbon monoxide gas. And this type of void would be impossible to produce without some kind of a very powerful emission coming from the center. In other words, the only thing powerful enough to carve out such a massive hole has to be hot wind blowing directly from the black hole. This is extremely unlikely to be produced in any other way. And to make sure there was nothing else here, they checked if there are any stars nearby, and if the stars were powerful enough to do any of this. But even the combined power of all of the nearby stars is not enough to produce such an enormous void, with all of this very likely being the result of wind blowing for at least 20,000 years. Indicating that, at least for the last 20,000 years, the black hole remains more or less quiet. But interestingly, there was also an additional study, in this case using X-ray observations. This was from a new telescope referred to as XRISM, by the scientists whose paper you can find in the description. And here this suggests that Sagittarius A star was definitely far from gentle, even relatively recently. And here this was established by looking at some of the molecular clouds very close to the center and discovering what scientists refer to as light echoes. Here's actually a kind of a visual representation of how this usually works. And this usually happens when something very powerful emits a lot of light coming from the center, and this light then starts to reflect from a lot of different clouds surrounding this object. And so here these clouds act as a kind of a cosmic mirror. And so in this study, by looking at the reflections of the X-rays, and by observing the light echoes produced as a result, scientists were able to definitively determine when the black hole was extremely active relatively recently. And that's because to produce these powerful emissions, the black hole had to become activated and release a lot of energy, with the data showing us that just a few hundred years ago, or essentially during the times of Galileo, Sagittarius A star flared up and became 10,000 times brighter compared to what it is today, essentially releasing all of this energy at once for reasons we obviously don't know. But back then, since we didn't really have X-ray observatories, none of this would have been visible, and the object would still remain hidden behind all of this dust. And so even with the most powerful 17th century telescopes, nobody would see anything in this region. But it still tells us that Sagittarius A star seems to be able to switch on from the sleeping mode to this fireworks mode relatively quickly without any major announcements. In this case, visible as these very powerful emissions inside a prominent molecular cloud referred to as G0.11-0.11. And because this particular cloud seems to have remarkably strong emissions that would be difficult to explain if it wasn't a black hole, It essentially confirms the somewhat unpredictable nature of central black holes, and also confirms that our black hole is definitely not some kind of a unique example. In other words, it confirms that the black hole in the center of the Milky Way produces powerful emissions once in a while and produces winds just like all other black holes in other galaxies. But it just right now it finds itself in this quiet state, mostly because there's nothing falling into it and nothing feeding it, preventing it from becoming extra powerful. And because a lot of these emissions and a lot of these winds usually sculpt the galaxy and even cause certain galaxies to completely lose the ability to produce stars, this usually happens when the wind becomes so strong that it basically pushes all of the gas away from the galaxy. Here, by studying these effects near the center of our own galaxy, we can learn about how this usually happens in various faraway objects, but also figure out what's going to happen to the Milky Way when one day it does become active once again, which at the same time might help us finally figure out this mystery of so-called galactic habitable zone, or essentially figure out which parts of the galaxy and what types of galaxies potentially have a high chance to host life on the surface. Because some research suggests that radiation and winds from active black holes can even strip atmosphere from planets within a few thousand light years away from the center. And so here this is actually something that's also important for studies in astrobiology and for researchers from SETI. But fortunately for us, we are 26,000 light years away from it, and so we seem to be outside of this danger zone. And so even if Sagittarius A star starts to have some kind of a major outburst, we're probably still going to be safe and basically just observe these new fireworks that we've never seen before. And well, anyway, so it looks like after 50 years, the winds have finally been found. And so now we can move from thinking that our black hole is unique and potentially broken to basically realizing that it's just a very typical phase for a supermassive black hole to sometimes take a very long nap. But as we get new tools and better telescopes, we'll probably be able to understand and even predict this much better and figure out what's going to happen to this black hole in the next few centuries. And maybe even be able to predict its next massive flare. For now, I guess we can rest easy knowing that this is definitely a black hole, but not a black hole that's going to destroy life on planet Earth. And since this black hole is also on a smaller side compared to a lot of other galaxies, chances are that this is maybe why we exist in the Milky Way galaxy, and not some other galaxy where a black hole is much larger. But we'll definitely come back and discuss these concepts in some of the future videos, and so until then, thank you for watching, subscribe, come back tomorrow to learn something else, support this channel on Patreon where you can find additional videos without any ads and can DM me directly, or by joining channel membership that grants you early access. You can also support this channel by buying the Wonderful Person t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.